record, Willie.
Try to record. I'll be right back in 5 seconds. Okay. All right. So I guess, but first we should start with taking a look at our exercise from the weekend. Speaking of which, is everyone good? Can everyone record? I don't see anything in chat, so I'm assuming everyone can. Great, good stuff. So I'm going to start by sharing my screen, and we're going to take a look at the exercise from the weekend. How did it go? Feedback.
Okay.
Okay.
Yeah.
Do you want to elaborate on that a little bit?
Okay. Yes. Elaborate. I went until extensions, and
Okay, that's good. That's excellent.
yeah, and I was having trouble with getting, what was that? Let me go back to what I got. So,
The extensions were very hard. Some of them.
yeah.
Some of the extensions were very hard. Dealing out cards.
The dealing, drawing just one card was one thing, but drawing more than one card for my code, I needed an array inside an array.
Okay.
Each time I draw, there will be new sets of array, like the first time array, second time array, and I needed to get into that, and it was kind of hard. It will crash all the time because I'm using while loop. So.
Okay.
Yep.
Okay.
But
excellent.
I figured it out.
Good. I'm glad that you got into that. Did anyone else get into any of the extensions?
Yeah, I finished the extensions, and I have the same problem where Zaria was encountered before. Yeah, just as Bruce said, your what you draw out of the deck is array of the cards, so you have to target at the first item in that array.
Yes, every time. Yes. Yep. And that was, I think I mentioned that on Friday, that when I was building it, that every time that we're pulling a card, and if I didn't, that it's good that you know this. It's important to know that. It's important to be able to find that stuff out, right? To look at what you're drawing, because if you draw one card or if you draw 3 cards, it's an array of cards, right? And so that's really important. So okay, cool. Well, good feedback. How long approximately did it take you? Sule. I'm gonna put you on the spot. How long did it take you about to complete?
I have a question about when I draw 5 cards to a person 1. If he got 0, then the game is over.
Yeah, I know, right? Kind of. Yeah. There's a couple little stupid things where the person who goes first has the advantage because if they draw all the cards first and they immediately get 0, the game's over and you haven't even dealt to anyone else. If you really wanted to take it to the next level, you would probably have to implement some sort of concept of a round, and score is calculated after everyone draws cards and looks at it, and that's like the end of a round. So round 1, round 2, round 3 type of thing. Yeah. So you probably have to do something like that. I don't know. I didn't do that, but I did think of that when I was writing the question. But you know, some of these things I just kind of say, oh yeah, I know, but you know, it's not about the finished product necessarily. It's about the journey. So we're working towards a journey. And sometimes the destination isn't necessarily great, like someone taking 5 cards and winning right away, but it is what it is. Okay, so let's get rolling here. And then after today, so after lecture, which will probably go on pretty long, we'll take a good break in between. I have your assignment, so you'll have all afternoon, all night, and then handing it in tomorrow morning. Okay. You won't have any exercises for the stuff we're doing today. It's kind of a two-part thing. Okay, so we're looking at our OOP card game. Okay, and over here on the right-hand side of the screen, I'm going to open a new page. We'll save it. Downloads. Card game. And I guess I have to go get my previous deck. I'll use the one that I put in chat. My computer is so slow. And we'll grab this deck of cards from here. Hopefully it all works. Did anyone have any problems with it? No? Good, okay. And so there's a couple different ways of approaching this. So what we want is we want two new classes. Right? We want a player class and we want a game class. The player class is pretty straightforward. So it'll look like something like this here. I'll just create a little bit of space here in between. I'm going to take away line 55 in between my deck. So we have our cards, right? We have our deck, we have our cards, which is awesome, right? We're going to start using this. So this is a huge benefit of where classes or the idea of object-oriented programming or classes comes into play, in the sense that like we have these pieces that already exist in our system and we don't have to go back into them and make changes. We can just start using them and we can build on top of them, right? So we have this deck and this card class can be reused over and over and over in any sort of card game that you want. Your game class and your player class might change, but the deck and the card class and all the functions, and all the methods and all the properties probably won't, unless you need like a very specialized type of cards. Like if you needed a deck with only ace to 10, right? Then you would have to change these classes. But generally speaking, you have this piece of code that's not going to change. And this is one of the main objectives of object-oriented programming. Not only that, but it allows us to make sense of the system a little bit more in terms of dealing with individual items. I'm dealing with a deck, I'm dealing with a card, I'm dealing with a player, as opposed to just this complex block of code trying to keep track of variables along the way. Okay. Now, of course, we have our complexities within these constructs, within these methods, but they're much smaller problems to deal with. Okay. And understanding the interaction between objects is very important as well. And that does add a layer of complexity. Okay. So we're going to start by creating a player class, because I know we need a player class. Okay. And a player class is pretty straightforward. Okay. For a player class, we're going to want, I think, what do we have here? 2 properties, a name and a hand. So this dot hand. Okay. If we think about a hand, and I'm not talking about one of these hands, I mean a hand of cards. Okay. An array, so in the example here, we have the hand, which is an array that we're going to want to be able to fill up with card objects. So we declare it in the constructor, in the player constructor, okay? This dot hand equals empty array. And what we're going to be able to do is we're going to be able to push cards into that hand. So that hand of cards is going to belong to that individual player. So again, object-oriented programming allows us to create instances of this player, and that player is going to be able to hold on to that instance is going to be able to hold on to their cards, okay? And so it adds another layer to kind of have objects keep track of things for themselves, so we can have multiple players keeping track of their own stuff, okay? And we don't have to manage all that. Okay, once we create the structure, so we have the hand, and then we have a name, a string representing the player's name. Now, I could do this. What's the problem with this? What's the problem with line 59?
Every player will have a name of Jonathan.
Yeah, every player is going to have the name Jonathan. That's not very ideal, right? When we're creating a new game, every player should have their own identity. Every player should be able to have their own name. And so that is how we typically decide whether or not we want to assign a value on line 59 or pass a value in as a parameter, okay? That's usually the distinction. Do we want every player to have the same thing, or do we want some variance between them? And so when we want certain properties to have some variance, we're going to want to pass those in as parameters. Okay. Okay, and and then the player has a couple methods. So again, as I mentioned on Thursday, where do all the methods go?
In the
prototype.
On the prototype. All the methods go on the prototype. So we've got score. That's it, just one. So to put a method on the prototype, if we can think back to the weekend, think back to Thursday, depending on the last time you programmed, we're looking at prototype. Sorry, that's not how it is. Player dot prototype dot the name of the method score equals function, and now our function declaration. Okay, and our function declaration is going to evaluate each card in the player's hand and returns an integer which represents the player's score based on the rank and the color of the suit of the hand. Now, without actually having cards in the hand, we can write this method because we know what a card looks like. So we assume that this dot hand is going to be an array of card objects, right? And each card object has a rank, and each card object has a suit. So I can imagine this. The problem is I can't test it once I write it because I don't actually have card objects in there yet, but I could if I wanted to. I can just add a couple to try it out. But I can actually start writing this right away, even though in the game I don't have card objects in my hand yet, because I know how card objects work. Okay, so this dot hand is an array, right? We know it's an array because we declared it to be an array on line 56. And this score method needs to go through all the cards in the hand, Okay, if you used a for of, or a for loop, or a for each, whatever you want, your choice. Okay, so here we're going through all the cards in the hand. And what are we going to do with the cards in the hand? Each card, right? With each card, we want to look at the card. Is it red or black? Now, cards don't have a method called red or black, right? Instead, they have a method called suit. Actually, I don't think it's a method. I think it's a
just a property.
It's just a property. Yeah. So they have a property called suit, and the suit will tell us it's either spades, right? Spades, clubs, diamonds, hearts. So while I don't have anything that tells me red or black, I do have something that tells me if it belongs to one of the four suits, and I know which two suits are red and which two suits are black. So I can say if the card, so we're going to have to, if we're doing a for each here, we have to pass in the element that we're dealing with, right? If the card dot suit is spades, is it capital S, lowercase s, uppercase s? Typically, if you were doing like a thorough application here, I would downcase everything all the time when comparing. I would downcase this on the left, and then this would be downcased on the right. That way you don't have to worry about going back and checking what it is. But because I'm being lazy this morning, I'm not going to. Okay, so we're going to check if the card is a black card. And so which two suits are black? Well, spades and clubs. Okay. If the card is black, what do we do with the score?
Minus equals.
Yeah. Well, we don't. The score goes down based on card rank, right? If it's black, the score is going to go down based on the rank of the card. Otherwise, if it's not a black card, that means it's a red card, and the score goes up based on the card rank. Okay. So the only problem here is we don't have anything to track score. Like we don't have a score to return yet. We don't have a number. So we need to create that number. Okay. And this is just going to exist within this method. And at the end, that's what we're going to return. We're going to return the score. And all we need to do is increase that score on red, decrease that score on black. So to decrease it, score minus equals card dot rank when we have black cards. Otherwise, score plus equals card dot rank. Okay, and return score. Now, unfortunately, I don't have the ability to test this out right now. If I ran it right now and said, create a new player, player.score, score would be 0. Yeah, score would be 0. Any questions on that? So this is my entire player class. All right, pretty small. Okay, it's not about big. It's not about being big. In fact, it's a lot easier to think of things and to hold things in your head when things are small. And so it's better to have, in my opinion, if you're designing a system, an application, it's better to have many small classes than many big classes, than a few big classes. Okay. It's just easier. A lot more moving pieces, probably a lot more lines of code, but those lines of code are generally a lot easier to understand. Hi.
Sometimes I cannot remember the objects that I coded before. So do you recommend we take a note and write down all the property and method?
There is actually a way to document your objects, which I don't teach. Most of them, they're called like most programming languages have something called something like Java doc or JS doc or C# doc. And what it is, it's a way of putting before your object, you put comments in a specific format, specifically formatted comments. And you highlight what are your properties and your methods. And then when you click generate, it will generate you a short piece of documentation that kind of looks a little bit like this, that says, here are the properties that your object has, here are the methods that your objects have. So in a really complicated system that for someone, because you're right, over time, as we start to create bigger and bigger applications, you might come to use an object that you wrote 2 months ago, or even 2 weeks ago. 2 weeks is a long time, and you forget what sort of properties it has, what sort of methods it has. And so you can generate that documentation with JS doc. Maybe that might be something worth looking into for us at some point in time. I don't feel as though the stuff that we're writing is that super complex. Hopefully in the back end, you'll have the opportunity to look at that. But you can take a look at that. I think it's JS doc. Yeah, JS doc. And it's just a little plugin. So you can put it on functions. You can put it on constructors. So represents a book constructor. And then it will output documentation that's not unlike the stuff that you would see on Mozilla, like MDN. Yeah. Then you don't need to take notes. And benefit of that too is other people can generate the documentation for themselves if they ever want to use your objects, like other colleagues who are working on the same application. Okay, so here's our player prototype. Here's our player. Here's our prototype method. And now we have our game class. So we're going to say function game. Now, game has a couple of properties. It has 2 properties. It has the this.players property, okay? And that's going to be an array which holds all the players. It also has a this.deck property, which is an instance of the deck class, because we need some cards to play with. So how you want to provide these things are up to you, okay? So for the first time I wrote this, I won't write it, I'm gonna do it a little bit different. The first time I wrote this, I took in an array of player names, just names. And then what I did was I looped through those player names inside this constructor, and I created new players based on those player names right in here. But I think what I would do this time is I would probably just pass in an array of players. Okay, now this is a little bit dangerous because I'm making an assumption that someone knows how to use this and they know to pass in an array of players. So when we say const game equals new game, I need to pass in an array of new players. So it needs to be an array of new players. New players. John. There. I'm going to play a game with my family. Okay. So this is what this would look like, right? I'm creating a new game. I probably would want to break this up into a couple lines because it's getting a little bit out of control there. And then probably these guys too. Okay, so I'm going to create a new game with 3 players in an array that I'm passing into game. Okay, so game has to have these players. In some manner, game has to have access to these players. And so it's an array. So this is one of the ways you can do it. If you don't want to do it out here and pass them in, you can just pass in player names and game can create the players for you. Those are really, I think, the 2 methods I would recommend. If you didn't want to declare these in line like this, you could have made another, like you could break this down. You can break line 80. This is 1 line, but you can break that down into multiple steps, right? Declare a variable of an array or declare 3 players, put them in an array, take that array and pass it into game. That's fine too, okay? However you want to operate. And those are the little differences that are going to separate each of us individually in terms of style. Okay. And now deck, you can pass in the deck of cards. There's a couple differences about why you might want to and why you might not want to. If you pass in the deck of cards as a parameter, the person using game, so this person, whoever decides to use game in their application, gets to decide. Now you're making game more flexible. You're saying, well, my game can use any deck of cards that I pass in. Okay, if I pass in the deck of cards. If I don't, if I force deck to declare the deck of cards, now deck is always stuck using the same deck of cards. So maybe I wanted to provide a deck that was only 26 cards. Well, I can do that here. I can do that if I pass it in. Then they can run 2 games. I can run 1 game with 52 cards. I can run the next game with 104, and I can run the 3rd game with 26. But if I hard code it in like this, every time I declare game, I'm stuck with this deck of cards. New deck, which is fine, right? They're just different approaches. This is saying all my games use a standard 52 card deck, unless I go change the code. Okay. What else do we got? And we have 2 methods to add to our prototype. Players, no. 2 properties and 2 methods. Scores to string and play. Okay. Game.prototype dot scores to string. And same thing, game.prototype dot play. Okay, so we have our 2 functions here. So let's do scores to string because it's really easy. Okay, scores to string is just going to go through the players. It's very similar to player prototype score. It's very similar to the score method on player. Okay, so similar. We want to go through each of the players, right? Loop through each player, get their score, add it to a formatted string, and then return that string. Okay, so those are the 4 things that I can see that we want to do. Okay, so we want to get their score and their name, right? Clearly we want their name. Add it to a formatted string and return that string. We have experience doing all of that stuff, right? Looping through an array, getting properties out of a function, getting properties out of an object instance, okay? Formatting a string. We did a bunch of string formatting in the last one. We did the stars and stuff. Okay. So we are going to do it like this. So this dot players is just like this dot hand, right? It's an array of players for each. Like that, fingers. Okay, and we're going to accept the player. And since this is, remember, for each takes a function, it goes element, element index array. And so this is element. It's just, I'm giving it the name player because that's what it is. It's a player. Okay. And what we're going to want to do is we're going to want to get the players. So we want to get their score. So player dot score is the method which will calculate their score for me. Okay, so I don't need to worry about calculating it. It's already going to get calculated. And I also need to get player dot name, but I need to put this in a formatted string. So I need to do it like this. So it needs to look like that. Player name colon score. So that'll look like this if I were to use template literals. So player name, player dot name colon player dot score. Okay, so in one line, and then, but I need to be adding this to a string that I'm going to output at the end. So kind of just like this, like we did in score, where I'm building up a score. Here, I also want to build up a score string, and I don't want to start it at 0. I want to start it at empty string. Okay, so we're going to start score string at empty. Then we're going to add to it, just like we did before. Okay, the only problem with this is this will all be on one line, right? And so if we want to put it on multiple lines, we have to do \n, okay? And that will create a new line after our score string. Not ideal for the last one. We can always just trim off that last character if we want to, but for this, I'm not going to worry about it. If this again were, if this were 3 weeks ago, 4 weeks ago, when this stuff was more important because we're learning it, I would say, yes, trim off that last character. That's super important. In this case right now, that's not the focus of what we're trying to learn here. But in a real life app, those little details do matter. So you would want to do that. Okay. By me not taking this off, I am lazy. And that is not, you will end up with a subpar app in the end. Okay. But I just want to be conscious of time. I know I think you could figure out a way to take that off if you wanted to. Okay. And then we're going to return this string. Okay. So that will print out our score for all the players. A single string. Okay. It does not, and I indicate right there, it doesn't print the string. It returns the string. So we're not console logging anything. We're printing it out. And you can start to see as we've graduated from JavaScript basics into advanced JavaScript, into more advanced JavaScript, most of our stuff is not most of our stuff is not console logging anything. A lot of our methods are returning things now because we care about the return value of them. Okay.
I have a question.
Yes.
So what about the winner declaration? Like John is the winner with the number.
That would be in prototype.
Oh, in the play? Oh.
Yeah.
Okay.
Yeah. So you'd put that right at the end. If you put it in scores to string, that's fine too. It's just, the thing is, when you put it in scores to string, you end up tying the fact that a player has won the game to printing out the scores. If you wanted to, for example, print out the scores after every round, you wouldn't want to put so-and-so as the winner because maybe we don't have a winner yet. So it's too tightly like connecting the winner to just displaying the scores, right? Okay, and finally, the last piece and the most complicated piece is the play method. Okay, so this is how we're actually going to play the game. We're end up going to use our last line of code outside of any class is going to be essentially game.play, and this will run the game for us. Okay, and it will call this function, and this function will have, now we have players have hands, a game has a deck. We need to take that deck of cards and have each player draw from it. Okay, so there's a couple of ways that, so that is probably one of the most important pieces here, is we need to draw from the deck. So we need to draw a card from the deck and give that card to a player. In addition to that, but before that, I would say we need to rotate through each player one at a time. And here's the kicker. When we reach the end, we start back at the beginning. So this is, so all of this is problem solving, right? But these are the types of fun problems that really I love to solve. I can look at it, I have ideas. It's not super obvious. It's not just an if statement, right? But so the way that you come up with the solution to this and the way I come up with the solution to this are going to be very different. We need to go, remember, players is an array of players. Okay, there's actually 3 players in this game. How can we go through the array, and once we get to the end, we start back in the beginning?
We could use a while loop.
Yeah, okay, beautiful. So while that, okay, but that's one piece. That's one piece, right?
Yeah, so we can use the while to set the condition that we're going to continue to draw cards as long as there's cards.
Okay, so these are kind of connected, right? We're going through the players, and we keep going. Like, so there's, how long do we go through the players, right? And the answer is, well, we keep going through 1, 2, 3, 1, 2, 3, 1, 2, 3 until there's no more cards to be drawn, right?
Yeah, that's right.
Right. Okay. So that's going to be that's a while loop. And that is the perfect use case for a while loop, right? We don't know how many times we're going. We can assume, right? We can assume we're going deck.length. That's another option. You go until deck.length is, until we've reached deck.length. That works too. Okay, so it could be a for loop. I like it as a while loop. Okay, while this deck and I forget exactly count, right? Once count deck, this deck count is 0, right? Because we don't want to, or sorry, greater than 0. Keep doing this as long as we haven't run out of cards yet. So that will keep this going. That'll keep these players picking up cards. How do we move? Well, I guess let's not worry about moving.
Sorry, John, your count is a method, not a property.
Oh, thank you. Okay, so now we're looping through these players. Sorry, we're not looping through the players. We're continuing to pull cards, okay? How do I take a card and assign it to a player?
Draw and push.
Draw and push, yeah. So this player hand right? We're going to push the card onto the player's hand. So this player.hand, we don't have a player yet, and that's the problem, right? We probably want to get a player. And in order to do that, we need to grab one from this players. Okay. We need to grab one from this players. I'm just going to grab the first one to start. Okay. And current player.hand push. We're going to push a card from the deck, and that is this deck.draw. And did I put that little extra function on here where it just draws one? It does. So if I don't provide it with a number here, it will just automatically draw one card. If I do provide it with a number here, it will draw that many cards. So when I built that method, I was thinking ahead. Okay, so draw. But as some of you know, okay, because this doesn't return one card, what does it actually return? An array of cards. It returns an array of cards. How many cards in that array in this case? One card. Why does it return an array of cards? Well, it returns an array of cards because you could have potentially asked for 2 cards. And we know we can't return 2 things. We know we can't return 2 things. The only way we return 2 things is if we put them together and return that one thing. So we're always returning an array. In many cases, in most games, it's going to be 1. But in some cases, depending on what type of game we're playing, pick up 10, right? We might have to pick up 10 cards, in which case we need an array to deal with that. So we don't want to just push that card right on to the player's hand. Instead, we want to just draw the card, which is going to return an array, right? It's going to look like this card, okay? And then we're just going to take the first or the 0th element from there and push it onto their hand. Okay, now they have a hand of cards, individual cards. That's the kind of shitty thing that you'd have to deal with. There's lots of ways that you can change this up, okay? But I think this is fine. Okay, so we know how to draw cards and we know how to put them on the player's hands. We have a player. Now the problem is we need to rotate through the players, because right now, the way this is working is when I run game.play, oh my God, birds, stop it. When I run this game, I'm going through all the cards in the deck and I'm taking them all for that player, this player right here. I need to be able to change this. 1, 2, 3, back to 0. 1, 2, 3, back to 0. Ideas?
Using for each index parameter.
Okay, use a for each loop with an index. So then would you change your while loop?
Oh, yeah.
Yeah, so you would use a while loop. Anyone else have an idea? Who else used a different approach?
I use a number plus, and then more the array length.
That is also what I did. Yeah. So Sule is saying, we'll just count this. Okay. So let's just say turn number. Each one of these is a turn. And we're just going to say, and actually this starts to make me think that maybe this would be better as a for loop, and actually might be better as a for, yeah, a for loop. Interesting, because I'm counting something anyways. I'm going to do that, actually. I'm going to rewrite this as a for instead of this. So let's do that instead. So instead of a while loop, which goes until count is equal to 0, let's just go up to cards.length. And then each, the only problem with that works in this very, very specific case. So we are going to go, we have to be careful that we can't call count. And that's the problem. Yeah, okay, we'll do this. We'll leave this. Sorry for going back and forth here. So we're just going to count turn numbers. Okay. And we're going to do that inside the while loop. So we're going to start the turn number at 0. Inside the while loop at the end, we're going to increase the turn number by 1. Just going to go up and up and up and up and up. And all we're going to do is we're going to mod that. So we're going to say turn number mod this dot players dot length. Right, because this dot players dot length, what is this dot players dot length? How long currently in this game, how long is this dot players dot length?
3.
3. So that means it will never, so the result of this will always be 0, 1, or 2. Because that's how mod works, right? 0, 1, or 2. Just like when we're trying to figure out odd or evens. See, modular arithmetic, always very powerful in computing. And that's what we're going, so this is either ever going to be 0, 1, or 2. And so we're just going to inject that right here. Turn number, mod this dot players dot length. and that will be 0, 1, or 2. And that will rotate through the players every single time. Okay. So that will pick another player. So pick a new player, either the first player, John, Candace, or Macy. Grab a card and calculate, and then move the turn number. Next player, draw a card, move the turn number. Next player, draw a card, move the turn number. Then it restarts right at the beginning. 0, 1, 2, 0, 1, 2, 0, 1, 2. Oh, we have no more cards left. Okay? Until we have no more cards left. Once we have no more cards left, that means we're done. We console log these scores. Okay. This dot scores to string. That will print out the scores, and we need to figure out who the winner is. And to figure out who the winner is, how did you, so right, is everyone following me right now? We're done drawing the cards, we print out the scores, and we determine the winner, and we print out that last piece. So-and-so is the winner with this many points. You can go through that array, you can loop through it, and you can find the biggest one. I sorted the array and then picked out the first element or the last element, right? Sort by score. That to me, that makes sense, okay? We looked at sort, so we have this dot player, this dot players, sort takes a function. Oh, my house. Got a baby crying, I've got birds chirping. This dot player set sort. Sort, remember, takes A and B, and A is essentially A dot. A is a player, so this is a player. Player 1. You can call this player 1, player 2, and if this number, we return something, and if this number is positive, it keeps them. If it's negative, it swaps them. I can't remember exactly if it keeps it or swaps it, depending on positive or negative, but that's what we want to return. We want to return a positive or a negative number. Player 1 dot rank, score. Right, score minus player 2 dot score. And that will sort it. And then we'll just pick out. So this will sort the array in real time. And then we just say this dot players console dot log this dot players 0 is the winner with, oh, this is name. So we just grab, after we sort it, it will either be the first or the last. If I have this wrong, then we'll find that we'll be able to figure that out because we'll be able to see it. Okay, and we can run this. And it should just work. So I got a problem with my score function. John, Candace, Macy, Nan. John is the winner with Nan. See, so that's the nice thing, is that I can kind of figure this out. I can see that it's a problem with the score function because I know where it's doing the calculations. And so clearly score, I use score here and I use score here. So clearly score is where the problem exists, and it's returning Nan. And it's returning Nan because I don't know. Cards.rank.
Value of.
Value of, where's value? Value of. Okay, so sorry, I don't quite follow what you're saying.
So I think some of the rank has the face cards. Maybe that's no, not that.
No,
Okay.
no. All my cards have a rank of 1 to 13. So I'm curious. So this is where I would use a console.log and say rank, and I'd run it again. And so it will start to print out the ranks for me. Oh, that's interesting. I never
found your suit, maybe.
Yeah. Card.suits.
Your
Rank.
suit is represented by numbers, not.
Do my cards not have suits?
They represent.
No,
They do.
no, maybe it's problem because suit is in plural, not singular.
Suit is represented by numbers, not strings.
Spades, hearts, diamonds, clubs.
Oh,
suit,
strange.
rank. Yeah. And card.new, suit. Okay, so let's see what. So then it should be hitting this else. If my if else is not working, then it should hit that else. One of them should work. Okay. Oh, this is card. So it is hitting that. It is hitting that else, which means this if statement is working. Undefined. What is card? Okay. A card is an array. Why is card an array? Did I not pull it out of the array when I passed it through? This.deck.draw. Oh, because I put it inside an array. Ugh, I'm stupid. And now it's working. And now this is working. Just a small syntax error. And there we go. Okay. So we've got a lot of extra stuff in there. So that's how I debug. I look for spots and then I start putting console logs and I print out things that I think are that, like, what do I expect to be there? I expect it to be these scores, these numbers. And when it starts printing out error or nothing or undefined or nan, right? That's how I start to realize, okay, like, this is not what I expect. This is not what I intended as a writer, right? Or as a programmer. That's not what I expected to get back. So something's going on here. Why? And then you start tracing things back. Okay. So I can get rid of these console logs because I don't need them anymore, because I kind of figured out my problem. And now, let's see. Clearly, I sorted my array incorrectly. So instead of sorting player 1 minus player 2, it's going to be player 2 minus player 1. And that should fix it. There we go. So and that's really strange that it got the exact same result. And again, it got the same result. Oh.
You didn't use shuffle in deck.
You didn't
shuffle.
Yes,
I didn't shuffle the deck. I didn't shuffle the deck. Probably something I should do. When do you want to do that? Well, you can do that right at the beginning, or you can do that in play. This.deck.shuffle. There we go. That's exactly why. Okay. There we go. Now we should get some more interesting stuff. There we go. Okay. And there you have it. Okay. Again, this is the most complicated part. A lot of the other pieces are just tiny little build a formatted string, loop through this, loop through that. But it's also about, part of this is also about getting used to the syntax, declaring the prototype, using this, doing all that stuff. Okay. Questions on this?
I have one.
Yep.
About the winner declaration function in the play.
Mm-hmm.
So I used the sort, same thing as you did, but the thing is, when the scores were same, there were like more than 2 winners. It only printed out the one that is after that or before that. So
yeah, and so like there's a lot of problems with this, right? As you'd mentioned before, there's I think one of you mentioned that if one person, if you do the extensions and you start with a hand of 5 cards and you get 0 right away, that person wins, and no one else even got to pick up a card. Problem. Another problem here. What if 2 people are tied? Then technically they're both winners. Or maybe it should say these 2 players are tied. But this doesn't handle that. And so that is not easy. Right now we're adding more levels of complexity, because sorting stuff and determining if players are tied does not work well, because now we can't, the reason why sort works so well is because we could sort it and just pick the first one, because we're guaranteed to know that at least that is the highest number. But the problem is, we know that's the highest number, but there may be another one that's the same right beside it. We don't bother checking. So maybe sort in that case wouldn't be the best. And so what we would have to do is we'd have to then say, okay, pick the first one. Is the second one also the same? Yes. Okay, now we have a tie. Well, is the third one also the same? Yes. Okay, now we have a 3-way tie. And so that just like makes it more and more complicated. And that is why we're paid the big bucks, because this doesn't cut it. If we were doing a real game, this wouldn't cut it. And we'd have to write more complicated code. Hopefully we would make a new method for that. That's called determine winner. And all it would do, so play would just do the play, and then we would say this.game.determine winner. And then that's where all the winner determining functionality would go, just to split this out to make this a little bit easier. But because it's still so tiny, we could have still moved this out to make it easy, but because this is so tiny, I think this is okay. Good thing to point out. Any other questions?
Sir.
Yes.
I got a question.
Yes.
So I didn't really get the this players that sort that function, like how yeah, I didn't really get it.
Okay, so we only looked at sort one time. One time, might have been 2 times we've looked at it, but the way it works is we need to provide it 2 items to compare. Okay, and what we're saying when we're comparing the 2, so we can just call sort like this, and it will sort it. JavaScript will sort it the way it thinks it should be sorted, which I can guarantee is not the way we want it. The way it sorts it is alphabetically. So it works really good on strings, but generally that's not what we want. So we want to give it a custom way of sorting. So we give it a custom way of sorting by saying, take any 2 elements in that array, and we just call them player 1 and player 2. Take any 2 elements in that array, right? When we're sorting things, what we need to do is we need to say, these 2 things in the array, are they in the correct order, or do they need to be swapped? And that's essentially, if we tell it how to do that with any 2 elements, JavaScript now knows, okay, I will use that same logic and apply it to all the elements. So that's essentially what we're doing. We're saying, just pick 2 elements, and here is how you determine whether or not they're in the correct order or they need to be swapped. And it is, if it is a positive, again, you'll have to check the documentation because I always get this backwards. If it's a positive number, if the function inside sort returns a positive number, we swap. Otherwise, if it's a negative number, we keep in the same. So we either keep them or we're swapping them. And by doing this, we're moving the player with the biggest score to the front of the array. And then we just take that player off as the winner. The person with the biggest score is the winner because we sorted it. Does that make more sense, Ray?
Oh yeah, yeah.
Okay.
I got it right now. Yeah,
Okay,
thanks.
excellent. Yeah, you're welcome.
I had a quick question too about sort.
Sure.
Sort modifies the existing array, right? It's not like a lot of the other array methods that actually create a new array.
Correct. Yeah. That's why I didn't have to assign it to a new variable here.
Right.
Now and it's fine, right? Like, not a big deal here. It's just rearranging the order. If we're thinking about players sitting around a table, right? It's just reorganizing where the players are sitting. We just have to make sure we do it after we're done handing out cards. Because if you think about it, if we resort them while we're dealing out cards, now all of a sudden players are going to be in a different order for the deal. So, yeah. How did you enjoy this exercise? Is it good? Maybe more enjoyable than some of the other stuff?
Took a lot of for me.
Took a lot of what?
Review.
Oh yeah, good. I'm glad that you. And so, how do you feel now?
Oh, a lot better.
Yeah, good. That's kind of what I'm going for, right? But it's a little bit more meaningful than some of the other stuff I usually have people do. Create cars, make each car honk, make each car drive. That's just a lot of like, if I were to compare that to practicing an instrument, I would consider that scales, your scales, right? You're just warming up your hands, you're just getting stuff down. This is more like actually playing a song, like a piece. Okay. Okay, now it's 10 o'clock. This would be a great time for a break. Go grab some coffee. Sule, take 15 minutes to nap. Some of you look like you're just backgrounds because you're so still. Like SAG, you're perfectly still on that blue wall and behind you. It looks like it's just a photo.
It's a decoy.
It is. I saw this.
Sleeping.
This showed up in my feed. How to convince your employer you're actually attending the meeting when you're not by using an animated background. So take 15 minutes, come back at 10:15 and get ready. It's going to be a rough ride today, but we'll get through it together, and trust me, it'll be fine. This stuff won't be on an assignment, but and then after that, we're going to have an assignment starting at 11:30. So we'll see you at 10:50. I'll leave the meeting open, obviously.
Okay, so we don't actually get the assignment till 11. So we don't actually get the assignment to 11.
You're not going to get it until after I'm done.
Oh, okay, no problem.
Yeah.
Oh, John, are you there?
Yeah, I'm here.
So when you check the chat, Bruce asked the question.
Oh, sorry. Yeah.
I tested in my browser, it's weird. Like if array is empty and if you check if it's equals empty, it's
empty, right?
false.
Yes.
Why is that?
Because arrays are objects, and two arrays, even though they contain the same stuff, are not equal, right? When just like objects, when we're dealing with objects or we're dealing with arrays, any objects at all, because again, arrays are objects, they're only equal if we're referring to the same array, not based on the content of the array. Does that make sense?
Oh, okay, I see.
Right. Well, I remember showing you this in class when we looked at arrays. But that's the reason. So there should be a method on arrays. Array is empty in JavaScript. So instead of asking if it's equal to an empty array, you either want to check to see if length equals 0. There is no is empty in JavaScript, unfortunately. In other languages, there's a function on arrays called is empty, and then you can just ask if it's empty, but you could always just check length equals 0. That'll tell you too.
Thanks.
Yep. I should have 21 people. And this is including myself. So we're 19, including myself. So technically there's only 18 people here. And I think we should have 21 people. So we're down a couple. And I don't know who.
Daniel hasn't come back.
Daniel.
Oh, Daniel? Did Daniel disappear?
I just talking to him today, though.
Yeah, well, whatever. So today we're taking all this stuff a step further, okay? So we're going to continue to talk about object-oriented programming, but we're going to take a kind of a brief pause, and we're going to dig into another benefit of object-oriented programming. And this one is specific. We'll talk about one of the benefits of object programming first, and I'll tell you what's specific about it to JavaScript. So with object-oriented programming, what we are trying to do is we are often trying to model real-world items, right? As you just saw. Now, a real-world item is not a game, right? In the example we just did, we did a game of cards. We did class game, function game to represent the game class. Now, I could never say, hey, that thing right there, that's a card game. Well, I guess I could, but we did model. So sometimes the comparison of objects in our system doesn't necessarily match all real world objects. Sometimes they're imaginary, okay? But for the most part, we're trying to build kind of conceptually real world objects: card, deck, player, okay? Now, as part of that, we have a principle called inheritance, okay? When I say the word inheritance, inherit, what does that make you think of? Who wants to give me an answer? When I say inherit or inheritance, what does that make you think of? Who wants to shout something out? Who wants to be the one? In real life. Saria, I see your thing glowing.
I'm thinking about my grandmother's beach house.
So yeah.
Perfect.
I was hoping someone would say something like that. Okay, so you're thinking about receiving something from an ancestor, right? You're thinking about receiving, in your case, your beach house from your grandma. So, and that concept is very similar to the concept that we're going to be dealing with in programming. The concept of inheritance is that some of our objects can inherit things, inherit functionality or properties from parents, from ancestors, from their ancestors. So far, we have been creating objects in isolation. They haven't had any additional people, anything additional connected to it, right? But in reality, under the hood, everything in JavaScript, all of our objects actually have a parent that they inherit some stuff from, that they get, that they inherit some sort of functionality or some sort of properties from. Okay, and in JavaScript, so every object so across the board, every object-oriented language has the concept of inheritance in some capacity. Okay, inheritance exists. All objects can have parent objects. So all classes, if you will, a class can have a parent class. And we'll look at what that looks like, right? We'll look at that today. Yeah, we'll look at that a little bit today, but we'll look at it in far more depth tomorrow. Inheritance across the board is something consistent for all object-oriented programming languages. In JavaScript, we call it prototypal inheritance because JavaScript uses something called prototypes, as we are now familiar with based on the last couple of classes. We've been adding stuff to prototypes. Okay, so JavaScript implements something called prototypal inheritance. Okay, and it's different than how other languages implement their inheritance. And that's actually something that makes JavaScript very special. Okay. You can also think of inheritance as something like genetics, right? You're born, you inherit when you're born, you inherit some of your parents' traits. Okay, eye color, shape, height, those types of things. What happens to your hair? Okay, these are traits that I've inherited from my parents, from you can argue ancestors as well, right? My dad, same thing. Okay? My dad's dad, same thing. Okay, we all have this inherited baldness trait. Okay, we share, but yet I am not a spitting image of my dad. So I've inherited a lot of his traits, yet at the same time, I have my own traits as well. And so that's where inheritance plays a role. So again, in JavaScript, we implement inheritance through something called prototypes. More specifically, it's called the prototype chain. Okay, the prototype chain, I have a little image that we'll take a look at, but I want to start by looking at it in terms of code. And so we'll flip back from the image to code, and we'll see how these things connect. On Friday, I sent out an image on just like how our objects and our constructor and our prototypes are connected. So we can take a look at that again. And then I'm adding another layer onto it, and tomorrow I'll add an additional layer onto it. Okay. As we've already seen, though, in JavaScript, JavaScript has a secret property. Okay, all of our JavaScript objects. So let me take this person object, very simple person class constructor here. Okay, we've got name, age, that's it. Okay, and I have a prototype for that person. with a walk function, person.prototype.walk function, console.log.
Are you sharing your screen?
Oh, no.
Okay.
You should just be able to imagine it.
Ah.
There we go. Okay. So on the left-hand side here. Left-hand side, I'm declaring a class person, okay, constructor function, name, age, super simple method, walk on the prototype, on the person prototype, okay, and function console log this.name. So whichever the person is, they'll start walking. So I've got a person and I have a method on their prototype. When I create a new person, actually, I think I'm just going to do all of this in here. Yeah. Okay. When I create a new person, okay, a new person called John, I have this John object, and you can see that right here in the browser. Again, this is because the browser is super awesome. The console in the browser is really awesome at demonstrating stuff for us. And we can see we have this person, John. Now, we have a secret property in here that we've seen before. I think we've seen this. When we open this, we can see these two properties here, but yet, so name, John, the property that we declared, name, age, 39, and then underscore, underscore, proto, underscore, underscore, object. That, and it's kind of lightly grayed out, if you will. It's a lighter shade of purple, and it doesn't show up when I print out the object, right? You can see it. This type of property, this is called a private property, okay? And you'll hear a lot more about private properties when you get to the back end. We've got two types of properties, public and private, and it's kind of secret, okay? It's not advertised to the world because not really everyone cares about it, but it exists. And when I open this, what do you expect to see? I think this should be review.
We should see the method for walk.
Right. So we're gonna remember, prototype is also an object, and it has a method on it. So that's why it says object. Okay. It has a method on it called walk. And sure enough, there it is. In addition, it also has a method called constructor, which is actually this thing. Okay, so it actually has this method. This method actually exists on the person.prototype.constructor. Okay. So when we print our person instance, we can look at, and if we're working on this in code, I can't just type in John, okay, and it will print out stuff. We need, if we want to look at the prototype, the actual prototype, we have to say object.get prototype of John, and this will give us the prototype for the object instance John. Okay, again, this is review. We've already seen this. This shouldn't be blowing your mind, but I'll make sure I go through it again. Okay, object.get prototype of, we pass in an object instance, and it provides us with prototype. This is also the same as saying John dot underscore underscore proto underscore underscore, but we don't want to do that because it's deprecated. But we get the same thing. Okay. One of the things that's really interesting is that when I type in John and I hit dot, I am provided with a list of properties and methods that I have created on John, right? So it's trying to say, hey, here's all the stuff that you created on John. Which one do you want to use? Do you want to use John.age? Do you want to use John.name? There was that invisible one on the prototype constructor. You can always type in John.constructor if you want, right? That's a function. You can also type in John._proto. Okay, as we saw, that exists. So or John.walk. Okay, so we know that these things, these methods and these properties already exist on John. But let's type in, let's just clear this. Let's type in John again. So we have age, name, constructor, walk. And now we have all these other things. Has a property, is prototype of. Property is enumerable. To locale string. To string. Value of. Where the heck did all this stuff come from? If I didn't add these things, where did all this stuff come from? __proto, we know that that exists on it already. Where did all?
Are they inherited from the objects prototypes?
So that's very good. Very excellent guess. Yes. So this concept of inheritance already exists in JavaScript, and we've already been using it without us knowing. So let's look at one of those .to string, and let's see what it prints out. Oh, it's a function. Object. This is, so everything has a toString. That's how it's able to convert things to string for us. Value of, what's value of? That's the value of. Hey, so the browser's actually using value of all the time whenever it's printing out their nice objects. So the big question was, where does these methods come from? I didn't add them. How could they possibly exist? And the answer is actually, it was staring us in the face the whole time. If I have an __proto, so, or in another sense, person has a prototype, right? Person's prototype is the same as John's prototype. Just to remind you. Okay, so these are the same. Okay. So let's look at that prototype. So we're going to look at this prototype, which we already looked at. It has walk and it has constructor. It has walk and it has constructor. And I'm going to open this. And it's got walk, constructor, and it has this other __proto available. It also, this prototype also has a link to a prototype. And I open that, and there I have all these additional methods that I was wondering where they came from. ToString, value of, has no property, to locale string. It's got a bunch of other stuff too, those __ things. Don't worry about those. And it has constructor, object. So this may look confusing to you. So let's take a look at this in a graphic. If you pop open your object-oriented JavaScript class. Okay. Oh my God, birds. And then there's an image here, simple inheritance in JS. This is essentially what we have. So we could save this image. Okay, so what we have is we have our person here, John. Okay, and this is our object instance we used up here. This is our person constructor. And this is very similar. On Friday, I essentially gave you these parts of the graphic, the parts just on the left. I didn't include this object, these two object, constructor and prototype on the right-hand side. So those are new, okay? So we have the person on the left, a person instance. Person instance has a prototype, underscore proto, and that's this object down here. Okay. Constructor is a function, but if you think of it, it's a constructor function. Okay. And it also has the walk, and the prototype has the walk function on it, or the method, the walk method. But it also has a prototype, just like this object has a prototype. This object has a prototype, and that is the object prototype. The object prototype also has a constructor, and we are actually familiar with this constructor. We were using it before when we were doing empty objects. This is our empty object constructor syntax. And if we look at A's methods and properties, you'll see it has all of those methods and properties from this object constructor, all the same ones that person, John has. So John has toString, value of, toLocale, and A has toLocale, toString, value of. The difference is A was created as a new object, and John was created as a new person. But every single object in JavaScript inherits from a top-level class called object. All of them. They all follow this pattern. Object has some object does have some properties, I think. No, has no properties. Object has no properties. This is empty. Person has properties. Person has name and age. So if you were to imagine in the constructor function, it should actually, I should redo this. Should have name in here, should have age as properties. Okay. You don't inherit properties. You don't inherit properties. You inherit methods through the prototype. Okay. So we don't, at this point, let's just say for right now, you don't inherit properties. You inherit methods through the prototype. So right now, when I create a new person, even if object had properties on it, I wouldn't be able to access those properties, but I am able to access those methods. The way the methods work is something called, and this is called the prototype chain. So we have person has the prototype, which is this, and this has a prototype, which is that. And tomorrow we're going to inject more objects in between here, and we're going to have a bunch of prototypes attached together. And it's going to form this long chain of objects connected to each other. And the way it works is that when I call this method, john.toString, how it works is it looks to see if I have that method on my person instance object to start. Does that method exist on my person instance object? In order for that to have existed on my person instance object, I would have had to put that method in the constructor, which is what we were doing before. Remember, we were doing this. Right, that's what we were doing before. And that would have put the method on the person instance. But we're not doing that anymore. So that you won't see that very often. Okay. Instead, it looks up at its prototype and it says, okay, the method does not exist on my instance. Mr. Prototype, do you have the method walk for me? And in this case, the prototype says, yes, I do. Here you go. Go ahead and use it. Okay. Now, let's take that same example, but let's use toString instead. So if I say John.toString, and then we look at this graph, it checks, does toString exist on person? Nope, doesn't do it, doesn't exist. Okay, go up to the prototype. Does toString exist on that object's prototype, the person prototype? Nope, doesn't exist. Okay, go up to the prototype's prototype. Does it exist over here? Ah, yes, it does. Okay, that's the one I'm going to use then. And that's how this inheritance works. So unlike, so if you're thinking of your grandma's beach house, Harold, your grandma, it's still your grandma's beach house, but you can use it, right? It's not, it doesn't belong to you, it still belongs to her, but you can use it, right? Do your parents have a beach house? No, but their parents have a beach house. Yes, I can go use it, okay? Now what happens if I tried to, if I don't have a beach house in my family. So if I tried to use a method that doesn't exist to the beach house, this method doesn't exist. Okay, let me just increase the font size of that. This method doesn't exist, but it has to go through the appropriate steps to find that out. First, it checks. Does beach house exist? Do beach house exist on person? Nope. Does it exist on the person's prototype? Nope. Does it exist on the prototype's prototype? In this case, object of prototype. Nope. Undefined. Error. That is where the errors happen. When it walks through the prototype chain, it walks up the prototype chain, and it finally discovers, oh, it doesn't exist. Error. Okay, so that's when the error happens. So this concept of inheritance here, it's not as though we're actually getting the things from the person. We're like much in the sense like we're inheriting them, like we inherit our traits. These are not my dad's eyes. This is not my dad's hair. But we're able to use those pieces of functionality. So person doesn't actually get them in JavaScript. This is how JavaScript does it. Person doesn't actually get them. Instead, person uses them. They are connected. And all objects here naturally are connected to person. So all objects that we create in our system automatically get this set of, get these connections. Okay, all of them. So they all get some sort of default methods and sometimes properties. And this type of idea where all objects inherit from some sort of top level object is very common in object-oriented programming. In the languages I come from, Ruby, everything is an object. Strings are objects, integers are objects. So everything has at least some base methods and some base properties, everything. So you can guarantee that no matter what whatever type of object you're using, they all have some sort of toString. So they can all be, so they can have a toString method on it. Okay, this is a two-part class. Because tomorrow is really heavy. I'm wondering if there's a little bit of something that I can pull in from tomorrow today. Now I feel like tomorrow needs to be all one thing. So we call this, this is called prototypal inheritance. In vocabulary, we would say the person class inherits from object, from object. So person inherits from object. Object is a superclass, Okay, we use the word superclass to refer to our parent. Okay, person. So object is the superclass of person. Person is the subclass of object. You'll also hear the reference parent and child. Object is the parent of person. Person is the child of object. Okay, so we have our instance person class, which is a subclass of object, or object is a superclass of person, super and sub. Okay, I'm sure we're familiar with those terms, especially when we're dealing with little numbers too in mathematics, super and sub. It's useful to be able to know how to navigate through these things, just so you can see how they're connected. So we have object.get prototype of John. And if we said John.proto, so I'm getting the prototype of John's prototype. And if we look at that, so that might sound crazy, but if we look at the example here, I'm getting the prototype. I'm asking, so John has a prototype and it's walk, right? And I'm getting the prototype of that prototype, which is going to be this object. And I end up with the object constructor, or sorry, the object prototype. Okay. And then I can ask for constructor, which is this thing up here. Move up to constructor, and that's that. And here's the object constructor function. Okay, if I wanted to, you would never do this. You would never do this, but it's a thing if you wanted to. Okay, I guess maybe one more thing I can show you that we haven't covered yet is how do we find out what is A? Does it have a name? They're actually, we can ask certain things about objects because now we're talking about inheritance. We can ask, is A an instance? Since A is an instance of objects, right? John is an instance of, what is John an instance of?
Person.
Person, yeah. John is an instance of person, right? And we say John is an instance, John is an instance object, okay, of the person class. So we can ask, if ever we want to know, if ever we would need to check something, hey, are you one of these types of objects? This would tell us true or false. But also, coincidentally, John is an instance of object because, right, it inherits from objects. So that inheritance, so as much as John is an instance of person, it is also, if you look at this chain, yeah, it's also an object. So John is an instance of person, but it's also an instance of object. So if we had a longer chain, John inherits everything up and down that chain. Okay, is A, our plain old object, is A an instance of person? A is not an instance of person. A is only comes from objects. Okay, so if I were to add A in here, it would be like around over here, and we have arrows pointing here. It doesn't get any of this stuff because it's not a person, it's just an object. Okay, so A is not an instance of person. A is an instance of object. Now, to maybe give you a better idea of how this might start to play out, if you think of, and this is the example we're going to go into next class. If you think about a person. I might have a system where I have two different types of people in my system. I might have a teacher, and I might have a student. So I have all teachers are people. All students are people. So every teacher is a person, believe it or not. Okay. And every student is a person. But not all people are students. Right? So this is kind of where inheritance can start to play a role, because teachers and students, we have a lot of similar qualities, lots of qualities that people have, right? We have things like names, ages, right? Nationality, gender, all these things. We all share these same qualities. However, I don't have some of the stuff that you do have. I don't have a grade. You have a grade, right? Instead, I have lesson plans. Okay, so this is where and why inheritance starts to play a role is we have a lot of similarities. So I don't want to have to copy all these similarities to here and to here. And however many other types of people we might have in our system, right? Instead, what I'm going to do is I'm going to take that stuff out, just like we did with with functions, take all these repeating stuff, take all these repeated pieces of functionality and methods and properties out and move them into a singular unit, a person class. And then all of our people inherit from that class. Administrators have something different. And this is just people at school. So that's the concept of inheritance. We're going to build on this example more tomorrow and actually build these out and connect all of them. Tomorrow is a really heavy class. Okay. How does everyone feel about this right now? To at least the understanding that this concept of inheritance exists, that object instances or classes, objects inherit from a parent, and every single object in the system essentially inherits from capital O object at the top of JavaScript. Does that concept make sense for everyone? Again, I have no exercises for you to do here today because I don't really feel like I can create some sort of exercise where you're demonstrating or practicing anything. If you want to get some practice, I would say go ahead and type around some stuff in the console. Take a look at this. Take a look at this diagram, and then I have a little bit of reading for you that outlines the same stuff. With the reading, don't go any further than ECMAScript 2015 classes. So if you don't read tonight, you can read tomorrow because this is going to cover everything. Actually, you could save this for tomorrow. You can save this for tomorrow. If you finish your assignment early enough tonight, you can work on that. But if you finish, I want to make sure you finish your assignment. Questions, comments, concerns? Not too much, actually. Not too bad of not as heavy of a day as I expected.
You know, I feel like we've seen kind of like the concept a lot, right? Like with the DOM and like the first element child and the parents, and even when we're doing CSS and HTML, depending on where our code is, it can inherit it all the way down, right? So
yep, exactly. This is not this is not really mind-blowing stuff. Tomorrow is it's not mind-blowing tomorrow, it's just the syntax. We're going to learn a bunch of new syntax tomorrow on how to actually do this. and it's going to be hard. And then tomorrow's Wednesday, and then on Thursday, I'm going to introduce you to a new concept, and all that stuff that I just taught you tomorrow, we're going to throw out the window. But there's some really important stuff that I'm going to teach tomorrow anyway. So, but yeah, nothing brand new. Yeah, good and good comparisons. It's a lot like DOM. It's a lot like CSS. Childs, parents, like none of that stuff. More CSS because CSS actually inherits from parents, whereas we don't have that here. Sorry, we don't have that for DOM as much. Okay, so let's take a look at assignment 1. I'm going to have to change the end date on the assignment because I think it's set for today at 8:45 in the morning, but it's going to have to be tomorrow at 8:45 in the morning. So I'm going to do that first, if it lets me run. What's the date today? April 14th. So we can start April 14th. April 15th is the deadline. Cutoff time, 8:50. So you cannot submit past 8:50 tomorrow morning. 8:45 is the deadline. 8:50 is the 5-minute grace period when you try to submit and your internet's being wonky. But don't wait till that deadline. Okay, let's take a look at assignment 1. Assignment 1. So we are looking, there's a difference now in comparison to what I was doing before. And I have readability points on here, okay? So we had readability before, but now part of readability includes thoughtfulness in your code. So before I was just more concerned with getting the right answer, and that is still my main point of concern. But if your code really starts to break down in how you're approaching your answer, then you're going to start to lose points for readability. And this is not objective. This is completely subjective for me. So I don't have a guide that says, this is how your code should look, right? This is, you've started to see a lot. If you're starting to do things really backwards or really poorly, you're going to start to lose points for that. And I'm more than happy to sit with you after and explain better approaches, okay? Why you should take certain better approaches. Now, again, this isn't going to be a large portion, but as part of the training goes, I want to see you improving in your ability to problem solve and take that problem and put together code that is thoughtful and intelligent, okay? Solves the problem in an intelligent manner, not just always brute forcing things, okay? Because we with brute forcing, we can do it, but it's going to be very detrimental to you in the long run. And so I need to encourage that thoughtfulness. So we're going to be building a vending machine, okay? So a vending machine is, as I'm sure you're familiar with, it's a machine that dispenses items. We have vending machines at school. They dispense drinks. We also have vending machines that dispense this type of stuff. This one is like candy and chocolate and stuff. Okay, so we're going to make a virtual vending machine, class vending machine, or sorry, function capital V vending machine. And it will have 3 methods: vend, repair, and add items. Okay, add items. Upon creation of a new instance of vending machine, so when we create the vending machine, we need to add all the items at once. So we will provide it with a list with an array of items. Here are the items to stick in the vending machine. In addition to the list of items to put in the vending machine, we also need to put money in the vending machine because, as you know, when you use a vending machine and you put in a $5 bill, you need to get change back, right? So that starting money that the vending machine has to give change back, that's called a float. Not a float like a number, but a float like a starting amount, okay? That's called a float, okay? So money that the vending machine can give out as change if necessary. So that's how our vending machine started, with those two things, an array of items and a float. Whatever you put in for the float is fine, okay? The method vend should take two arguments: the selection, a code that matches an item, and a quantity of money in decimal. It could be an integer, but not a string, okay? And a quantity of money. So you're essentially putting money in. The idea is machine vend is a person putting money in and then clicking A8, or in this case, A1, okay? And
so sorry. We don't need to worry about the like how many items we're going to
Yeah, you do. But you're only ever asking for one, right? You only vend one item at a time. And I think that's pretty consistent with vending machines. You put money in, you pick A1. If you want another chocolate bar, you put more money in, you pick A1 again, or A2 or A3. In terms of, we're not concerned with how many, yes, we are. Because as you can see, you can use this array of items to start with, add items, or not add items. When you create a new vending machine and you want to give it an array of items, you can just use these items, or you can create your own. If these items aren't suitable for you and you want to use different items, that's fine. It's different items. These are all fine though. Okay, and you can see they have a quantity. Okay, now here are the requirements. If the money that the person puts into the machine when they ask for an item is not enough for that item, we return not enough money. You can console log it if you want, okay? But like, I want to see something like either return or console log. Doesn't matter. If you return it, it won't print it out. If you console log it, it will print it out. Doesn't really matter to me. Okay, so if you don't put enough money in, you return not enough money. If the quantity is 0 for an item that you're asking for, return out of stock. This means you need to decrement the quantity when you're, well, actually that's number 6. Okay, so if there's 0 quantity, for example, if you try to buy caramels, there's no caramels in the machine, quantity 0. Return item name out of stock, caramels out of stock. Okay, if the item is correctly selected, so the item exists, we gave them enough money, vending item, so you will return vending item name with however much change. So if I put $10 in and I bought Smarties and I asked for Smarties, it will say $10 minus 160. So Smarties, so vending Smarties with $8.40 change. Number 4, if an item is correctly selected and there is no change needed, then return. So if item is correctly selected, Smarties, and I put an exact amount, $1.60, return vending Smarties. That's it, no change. Okay, so not with $9.40 change. If an item is invalid, that means I picked Z20. Well, there is no Z20. Okay, our vending machine says invalid selection, and it just returns the float, the value of the float. Number 6.
Sorry, I have a question.
Yeah, go ahead.
So the value of float is whatever the initial amount in the vending machine, right?
Yes, but that is going to change. So number 6, if the selection is successful, the float is going to change, right? Because if I put in $10, if my machine is selling product, that means my machine is collecting more money. And so the float is going to increase.
Okay.
Right?
Yeah.
Yeah. So at the same time as my float increases, the money, the starting amount of money in the vending machine, think of it like you're a cashier. As a cashier, you get some starting money. And every time you sell a product, you put more money in your till. Yes, you give change, but at the end of your shift, the amount of money in your till is going to be more than, it has to be 100% more than when it started. If you're selling products and you're taking money and you're adding more money to your till, if your till is less than when you started, you're not going to keep your job very long. Okay. You have to have more money. So the vending machine is the same idea. Even though we're giving out change, we're still making $1.40, $1.60, $1.80, $1.35, 25 cents every time we sell something. Okay, we don't give out change for no reason.
John, just another question then in regards to that.
Yep.
Are we given a default value for our float or?
Yeah, you can use whatever you want.
Okay. And then
I would say like
one other question.
$10 or something, yeah.
For your example of items array, do you care if we just use your example? Or do you want?
No, please use mine. It's easier.
Thank you.
Yep. Number 6, so we're increasing, when we sell a product, we're increasing the float, but we're also decreasing the quantity of that product. Okay, we're decreasing the quantity of that product. Number 7, if the vending machine, not never, ever runs out of money, which would actually be impossible. Number 7, ignore. We're going to pull that out because it can never run out of money. The float can never be 0. Because like I said, as long as it keeps selling things, the float will keep increasing. Change, everything handled here is always to 2 decimal places. Okay. Number 9, we can add individual new items to the vending machine. So now we're looking at it from a different perspective. The vend method is really for the customer. I want to buy something from the vending machine. But we also need some way to put new things into the vending machine without creating a brand new vending machine, right? Because that was how we put things in initially. So we can add items to the vending machine, which takes a single object. We can add new items to the vending machine. And it returned, and it should print out the message, item name for item cost. So new item, new product available, item name for item cost. But we can't increase the quantity. We can only add a new item. So I can add a new chocolate bar. So I can put like something under code C3, C03. So I would add a new individual item. So I would take one object and I would pass it to my item, or however you want to do it. However you feel like you can achieve this by providing new information, okay, to your vending machine. And it creates a new item. If that item already is using a code, so I can't put another item under B02. I can only create a new item in the vending machine. Okay. And finally, the last piece. Interestingly enough, our vending machine breaks down fairly predictably. Every 10th sale, the vending machine goes haywire and everything stops working until we repair the vending machine. So we can't do anything else except call repair. Okay, number 8 I'll take out. So number 8 doesn't count. And that is it. Your vend method will be the biggest one.
I think it's number 7.
Yeah, it's number 7. It's not number 8.
Oh, thank you. Cool. All right. So that's it. Questions, comments, concerns?
I have a question about the last one.
Yep.
So if the machine just breaks down, so if I call vend or add item, they just don't do anything, right?
It just prints out the string of gibberish.
Oh, okay.
It prints out this string of gibberish every time vend or add item is called. So everywhere that it says return, you can just say console log. Then you can actually get feedback from your machine. So just, you don't have, your methods don't have to return anything. They can just console log stuff. Okay. So wherever it says return, 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 return. And I have this on tape. You're recording me saying this. Okay. Console log.
And for number 5, should if an invalid item is selected, should it return the money that the customer put in instead of like the total amount of the money in the machine?
It just, I mean, it in reality, yes. Just don't add it to the float.
But here you want us to print out the float, right?
Yep. And so yeah, if it doesn't just steal the money. Yes. That'd be a pretty bad vending machine if it just took the money and added it. Great questions. Anything else? All right. So you've got the rest of the day to work on this. This is an individual effort. Okay. I expect for the most part that a lot of yours are going to look very different. So it's an individual effort. Me and Zach are here to provide support in a limited fashion. Okay. Very different than how we would support an exercise because this is an assignment. So I'd be more than happy to answer clarifying questions just like Yushin had. In fact, I invite those types of questions, obviously. But with respect to why isn't my code working, okay, at this stage in the game, I really expect you to be able to handle most of that stuff on your own. Yeah, you've got all day. I don't think this should take you more than a couple hours, honestly. But that's why I'm giving you the rest of the night as well. It's, in all honesty, it's not really that hard. I think the stuff that we've been doing so far has been much more difficult than this. So I think you'll find this to be quite a bit easier once you get going. Might take a couple, like anything new. Whenever you're building anything new, getting started is always the hardest part. But once you've started and you get the ball rolling, I think things will flow pretty quickly because you'll start to see a pattern emerge. Yeah, if you have any questions, again, Zach and I are available. So please shoot them our way and we'll be around.
The assignment hasn't been shown in the.
Yeah.
Oh, you're trying to start on it already. Okay. Yeah, that would make sense. I should probably release it and show you. Okay. All right. Now you should be able to see it.
Oh, I have one question.
Yep.
So, write the code, and do I call like repair, like add items?
You don't
have to call.
You don't have to call. You don't have to actually use your vending machine. You just have to create a vending machine.
Okay.
But if you're not using your vending machine, that means you're not testing your code.
Yeah.
Right. Which means like you should at least, you don't have to submit that part to me, but I recommend doing it. Right?
Yeah.
You should create a new vending machine. You should sell some stuff. You should make sure everything's working, but you don't have to submit that part to me. No, I just want the vending machine class. And remember, where do the methods go?
Outside as prototype or something.
On the prototype.
On the prototype. On the prototype. It doesn't say that anywhere here. I expect you to know that now. Okay, methods go on the prototype. All righty. 11:16. I think I'm gonna take lunch now instead of sitting around for 14 minutes. So I'll be back at 12:15 or around that time on Discord. So shoot me a message if you have any questions. Good luck. 8:45 tomorrow morning. This thing's due. Okay. Don't be late. Don't miss